A cylindrical shape is another consideration we may have when doing related rates problems. A water tank has the shape of a cylinder with a base of radius 2 meters and a height of 4 meters. If water is being pumped in the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising. So we've got this cylindrical tank, looks like a giant Coke can, or soda can, if you will. And they tell us the radius here is 2 meters. Notice that's not going to change. This height, the whole height of this is 4 meters. All right, so we've got a 2 meter by 4 meters. They want to know how the water level is rising. So our unknown is the height. If this is the water in the tank and it's rising, look what's changing. dH dt is our change in water level. So what is dH dt? I don't know. They tell us that the rate that the tank is being filled is meters cubed. So they've given us dV dt. I can just look at the units and tell you that dV dt was given. That's min. All right. They gave us that R was 2 meters. All right. So here's the key equation that relates all of these variables together. The volume of a cylinder is the radius, the area of the circle, pi r squared, times the height. So pi r squared h. Now, we have two variables here. If you leave these as two variables, we'd have to consider this f and this g. And remember, y prime would be f dash g plus fg dash. And you certainly could do that. You certainly could do that. But if we replace the r, look, the radius is not changing. So we could say that the volume of the tank is equal to pi 2 squared h. So volume in this particular case is 4 pi h. Now volume is in terms of one variable h. So now when I take the derivative of both sides with respect to v, I get dv dt is equal to 4 pi, that becomes a constant, times dh dt. Now this is what we're after. If we replace dv dt with 2, we get 2 is equal to 4 pi th dt. So dh dt is equal to, I'm going to take this side divided by that side, 2 over 4 pi is equal to, well, if I cancel, I get 1 over 2 pi. Notice, if I do this on a calculator, I need to put those parentheses there and then the right units. And when I plug in my numbers, I get about 0.16. Now it's dH dt, so that's meters per minute. And look, the water level is rising, so our rate of change is positive there.